Hi, it's Robin. I've got here a little game prototype I've been working on, tentatively called Descending Doom. Just try it for a bit. A joystick here, it's for the Commodore 64. And the graphics are not much to speak of, but as I said, it was a prototype. And the idea is you're that little, I guess it's a ship, little character A. And all this doom is coming at you. Wonder if I can keep talking and playing this at the same time. And the idea is you just have to shoot it all before it reaches the bottom and kills you. Kind of Space Invaders-esque, but they're not shooting at you. And instead, there's just a whole lot of whatever these are, blocks. I've gone through a lot of iterations of this. I just coded this over the last day or two. The ideas keep changing. I keep tweaking it. For example, didn't have auto fire at first. And then actually after a while, I realized even I made it just shoot when you held down the fire button. And I realized my hand was kind of cramping up from just holding the fire button all the time. So then I changed it so you didn't even have to press fire. And you could press the button to actually stop firing if you wanted, which might occasionally be useful. I tweaked it a lot for the speed. I mean, the speed of the descension of the doom coming at you. I've tried to find a good balance where it's difficult but not too difficult. I might be making it look kind of easy right now. And the rate of the descent actually increases as you play. Oh yeah, and the fire button no longer stops you from shooting. Instead, it enables kind of a single step mode where you have to push the joystick left or right distinctly. You can't just, it needs a new tap each time you move. And that's kind of to help line up exactly with the column. Because otherwise it's a little bit twitchy where you might overshoot the column because it is moving pretty fast. There, that's where it comes in useful. Just hold down the button and then tap the joystick in the direction you want to move. Okay, well, I've almost finished the game, so I guess we might as well see it through. Now, this might seem, I don't know, probably some of you will actually really enjoy this game. I actually do, not just because I made it. It's the kind of game I like, this kind of working towards a very clear goal and kind of resource time management. That's not what this video is really about. It's what I opened with. Here, I'll finish off the level. Hey, winner! Okay, so what this video is really about, on the title screen, it says written in Hare Basic. Now, if you've done much Commodore 64 programming, you know that Basic is pretty slow, and you never be able to do things like just the speed that that asterisk, the bullet, or whatever, the fire moves at, or when the whole wall descends at you here. That's done almost instantly. The game does slow down ever so briefly, but overall the game keeps running at 60 frames per second on NTSC. Oh yeah, you might as well see game over here as well. Oh, there, game over. This game is written in BASIC, even though it's approaching machine language speeds. How's that possible? Well, I'll press stop here, break in 1040. If I list the program, it does appear to be BASIC. And the whole game is only a couple screens long. Again, this is just a prototype. Maybe I'll dress this game up or have somebody help me do nicer graphics on it or whatever and turn it into a complete game. But it was mostly so I could play around with this. So the big clue that something's different, and this isn't just standard BASIC, is here on line 5. A equals USR, that's a user machine language call, to 100. Well, that's the line number of the Hare Basic program, H-A-R-E, as in that famously fast rabbit. So the actual Commodore Basic program is just line 5. Well, I've got line 1 here commented out. We don't even need that. I was just using that for checking out key scan codes at one point. I can actually just delete that now. So line 5 is the regular Commodore Basic program, and starting at line 100, this is written in Hare Basic. Okay, so what is Hare Basic? It was just released in the last few days, written by Alexei Eben, who is a brilliant 6502 programmer and musician. He's developed games, made lots of music. A very interesting guy from Finland. About 5 years ago, Alexei made something called Bunny Basic, which was similar. I played around with it a bit and never did get around to making a video about it. Sorry, Alexei. But I'm making up for it this time by covering Hare Basic when it's brand new. And I think it's really worth checking out, especially if you like programming the Commodore 64 or VIC-20 in BASIC on the real thing. It's definitely worth checking out and playing around with. So it's available for download. Check the video description for a link. And it includes a D64, which will work on either the Commodore 64 or the VIC-20. And there's an excellent PDF manual. So just to read the introduction from the manual, the handbook. So Hare Basic is a fast, limited instruction set, integer-only basic interpreter, not a compiler, for Commodore 64 and VIC-20. You can see there the list of commands. Most of the key Commodore Basic commands are available, but not all of them. It has just 26 variables, one-letter variables, A through Z, and they're all 16-bit unsigned integer, and they are not shared with CBM, Commodore Basic. And it just has some limited string functions. It doesn't have regular dynamic strings. All those restrictions, and there are quite a few, pay off with Hare Basic being much, much faster than regular Commodore Basic. I think it'll vary, but I'm often seeing it being 10 times faster than regular C64 Basic. Certain things like scrolling the screen with a memory copy, there's built-in utilities for that in the language that essentially function at full machine language speed, which is at least hundreds of times faster than Commodore Basic. By the way, I find Hare Basic works well with Jiffy DOS, but it interferes with the wedge commands on Super Snapshot, so I recommend using Jiffy DOS over Super Snapshot for Hare Basic, at least currently. So the Hare Basic D64, you just load Hare Basic on either VIC-20 or Commodore 64 to boot it up, and includes a bunch of demo programs, some of which will work on either platform. Some are 64 specific. I'm just going to focus on the C64 version today. There'll be more VIC-20 videos coming pretty soon, I think. So let's load up Balloons. And this is one of the example programs. Okay, so less than a full screen of code, and we'll run it. There it is. There's, I believe, all 8 sprites moving. And again, this is in Hare Basic. And you know that C64 Basic can't move that many sprites that quickly. And Stop Restore preserves Hare Basic. So you can feel free to press that to escape. So we'll look at this program. Hare Basic is interpreted basic. Commodore 64 Basic is also interpreted. Both interpreters coexist. Hare Basic doesn't replace Commodore Basic. Both languages are actually available at once. Commodore Basic is sort of in control. When you type run, Hare Basic isn't active. And it's this command, A = USR, that calls Hare Basic code. And you give it the line number that you want to execute from. So line 10, this is Hare Basic here. Now, Hare Basic and Commodore Basic look extremely similar. They share the same editor, and in some cases, because there is overlap with the languages, you could run some code with either interpreter. But of course, there are some things that only work in one or the other. And you could, if you wanted, even just write certain routines in Hare Basic. You can make a big C64 basic game and makes good use of Commodore string handling and so on, but then uses Hare Basic to greatly speed up certain sections. And it's just as easy to write as regular Commodore Basic. That's why I'm suggesting if you are a Commodore Basic programmer, you might want to try this. And actually, the way it structures code is closer to assembly language, so it's actually helping you to think even more like an assembly programmer. So just to show some of the differences here, you can print literal strings just like in Commodore Basic, so that's clearing the screen. You can set variables, but again, in Hare Basic, they're only single letters. You just have A through Z available. And in fact, A, X, and Y and Z are partially reserved. They're kind of special variables that are used in interaction with assembly language routines, kernel calls, and also some of Hare Basic's own special instructions. So those are just saying regular variables. And again, they're unsigned integers, meaning they can go from 0 to 65535 decimal. But here's the difference. You can load files, but it's always a load, 8, 1 equivalent, that is, loading to a specific location in memory. But the second parameter is the address where you want the file to load. So this balloon sprite is being loaded from disk, from device 8, to location 832, so the sprite definition is there. And now this for-a loop looks just like regular Commodore Basic. Note that no white space is allowed. Yes, my bad habit is actually enforced with Hare Basic. So if you want to go for-a like that, nope, you'll get an error. And so all 8 sprites are being poked to sprite definition 13. That is location 832. 13 times 64 bytes for each sprite definition is 832. Okay, R is the base register, and so on. If you've done any Commodore sprite programming, then this will all look very familiar. Now what's happening here is A is being set to 0. Later on here, there are these special Go routines. I'll show a big list of them. So Go2 just waits for the vertical blank for the raster to reach the bottom of the screen. And that's done both to synchronize code with the video display, so it'll run at a steady 50 or 60 frames per second on PAL or NTSC. Now Go14 actually places a sprite A, so the number from 0 to 7 goes in the accumulator, and the X and Y position go in the X and Y variables, and Go14 will position the sprite in that location. Hare Basic also has C-style variable increments, so going A plus is like, when C you go A plus plus, on this you go A plus, and that increments that variable by 1. And then X and Y are being redefined. So now we're positioning sprite 1. And here, A plus, this is sprite 2. And it just keeps calculating the X and Y. And Go14 positions the appropriate sprite. So all 8 sprites are positioned. And C and D are also changed. Those are just being used as variables in various formulas to move the sprites across the screen. Actually, I press stop. It actually is monitoring the keyboard here. Get A. Normally, Commodore Basic, you would get a string, but because there's no dynamic strings in Hare Basic, instead Get A puts the character code in the accumulator, a numeric value, 0 if there's no key. So actually, when I ran it and I stopped it, all the sprites stayed on screen. But this program's actually watching for you to press a key. And when you press it, the sprites are turned off. The Hare Basic code returns. When the program ends, it runs out of code, or the command end, or a return from a subroutine, then Commodore Basic comes back in control here, and the program is listed, which ends the program. Okay, so that's a balloon sprite demo. What else is included on here? There's a FILLSPEED program. Okay, and we'll run this. So what it's doing is filling the screen under Hare Basic control and then under regular Commodore Basic control. And we're definitely in the Commodore Basic section now. I'm going to fast forward some of this because it'll actually give times at the end and you'll be able to see how much faster Hare Basic is at this. Okay, so after that's all done, so the memory fill speed benchmark, fill screen memory 15 times. Regular Commodore Basic takes 3295 jiffies, while Hare Basic in a 4nex loop takes 295, so that's more than 10, it's about 11 times faster. And if you use the Go system call to do the job, it only takes 15 jiffies, 60 jiffies to a second, so it takes a quarter second, or about 5 seconds, or whatever that is, 3295 divided by 60, I can't do it in my head, eh? So this is about 55 seconds versus 5 seconds versus a quarter second. And you can see the code here. What's done is in each case, you've probably seen benchmarking like this in some of my videos before. TI string is set to 0, that's the system clock. And then different routines are called, with Hare Basic calling line 20 and tracking its time in E, calling line 10. So these are the 3 different benchmarks being done. In each case, the time it took to run is stored in one of our precious variables, C, D, and E. So this is an interesting place where we can see Hare Basic and Commodore Basic coexisting. On line 2, Hare Basic calls line 10, and on line 3, Commodore Basic also calls line 10. So let's look at line 10. So this is a line of code that can be executed by either interpreter. So there's a loop. So 5 times this is called, and that calls line 110, which fills the screen. So that's all 1000 bytes of the screen being poked, first with character 160, then with character 102, goes to 110, and then 32, which is the cleared screen. 160 is the inverted, like a solid square, and 32 is the regular space or blank character. 3 different fills are being done 5 times, that's why it's 15 times. And note that either Hare Basic is doing the Go sub 110 or Commodore Basic. So exactly the same code running 11 times faster just because of the optimized Hare Basic, which of course does have a bunch of compromises, but it can be totally worth it, especially for programs like this. As it says up here, the third call that's super fast is the Go system call. And that's right here, where you set the X variable to 1024, that's the beginning. Y is the end of the range, and you set the accumulator to the byte that you want to fill with, and then call Go 3 from our list of Go system calls. That's what does that fill in a quarter second. Another interesting one here is this RASTER routine. Short little program. We'll run this. And if you see that the borders are full of raster bars, you actually have to hit stop restore to get out. And that's probably because the timing's too sensitive to start reading the keyboard in here. Those are created by rapidly changing the border color, but in sync with the CPU. So it appears to be a more or less stable image. You can see it flicker a bit. It's probably timed better on PAL, but that is very good for BASIC. Actually, I'm curious here. What happens if I change this, the register, to 53281? There. You get a better look at the raster display. So you can see some flickering, and that's because it's not totally stable. It's not quite fast enough and not lined up so that those transitions between border colors are happening in the borders where they're not visible. That might be something that can be improved on for NTSC. It's probably perfect for PAL. So how's that done? Well, again, Bunny Basic is called. Starting at line 2, just prints that top message, and then the 53280 is the VIC register for the border. So we have a loop 9 times for A equals 1 to 9, poking that border color with C, then D, then E, then F, then back down to E, D, C, B, and the loop repeats. Variables B through E are just different colors. It's like a grayscale. B is white, and then these are different grays, and F is black. So it's just rapidly changing the different border colors. And I think it's using variables because that's a little faster than parsing a literal over and over again. Okay, so this is a longer program here called tips. And I think if you run it, it just lists part of itself. But it gives different examples. For example, here is string poke example. So you can poke strings to the screen. Infinite loop example. Oh yeah, you can do go to or go sub to a variable, which isn't possible in Commodore Basic. So that could be very useful, as you could calculate a line number that you want to go to. Variables persist until clear. When you start a Hare Basic program, the variables aren't automatically cleared, and that's to facilitate communication between different Hare Basic routines in the master Commodore Basic program. Return as the end of a Hare subroutine. Yeah, you can use return so that you can call the routine from either Hare or slow CBM Basic. There's a way that you could still use the input command. You can scroll the screen down on the C64 VIC-20, and that's actually what I'm using in my program. Choosing a random number. Oh yeah, certain commands have been changed, like RND. If you look on line 810, in regular Commodore Basic, random is a function, and this has been turned into a command. And when you do RND, it just puts a random value from 0 to 65534 into the A variable. And why not 6635? Well, it's because it's using a pseudo-random number generator. There's always one value that locks up, like effectively a 0. If the pseudo-random number generator is full of all zeros, or in some cases all ones, then it doesn't work anymore. It's it gets stuck on 0. So there's always one value that can't be used. So examples of how to get other random numbers. From 900 on, bit shifting examples. So yeah, there's a go 8 and go 9 to shift the accumulator. Well, I call it the accumulator, the A variable, by Z bits. Screen memory locations. Okay, so there's lots of examples. I'm not going to comprehensively cover everything in this language, but one more thing we're going to look at is my game. And I'll include a D64 with my game on it. As of when I'm making this video, version 17, game 1.7, is the latest one I have. I may update that again. Okay, so we'll just look through the code. Part of why I programmed it was just so I could get a grasp of the language. So again, just starting the program, calls Hare Basic and ends, but actually I think it never does actually escape. So that end is never called, but it's there just for good measure to prevent Commodore Basic from starting to execute Hare Basic code. And I did put remarks in. I went pretty light on them. They do slow things down a little. GoSub 1000 displays the title screen. Oh yeah, I had accidentally left a space in there, and actually the whole thing crashed because of that space, but Alexi's fixed that since, I think. I'm going to try that. Oh yeah, now it says undefined statement error in 105. But basically, if you get weird errors, look for spaces. That may have been the only crashing bug, and Alexi's fixed that. But if you do find any weirdness, always look for spaces. That was done, again, just for speed, and it's just one of those compromises. Print character string 147 clears the screen. And then what I did, a for I loop from 1024, which is the top left of the screen, to 1823, which is down around here somewhere. I'm just going to loop through the screen, call random, which, as I said, just generates a random number and puts in the accumulator. And then A and 1 effectively turns the random number into just 0 or 1. And we store that in variable B. And then we take B and multiply it by 128, put it back in B. B equals B plus 32. And then we poke the I screen location with that B we just calculated. Okay, now why is this so long-winded? Well, another compromise Hare Basic makes is that you can only do one calculation per statement. There's no order of operations, there's no chaining commands together, and this is just another compromise to speed the program up. And there's no temporary variables either, so you can't do a little bit of math in here, like poke I plus something, or poke B plus something. You just have to do it in previous statements. But at least you can just keep reusing the same variable. I suppose I could have just used A for that as well. I think those variables like A, X, Y, and Z. Z, by the way, is used to set or clear the carry flag after a routine. Oh yeah, and A, X, Y will receive the values from the accumulator X and Y when a machine code routine is returned. The Hare Basic variables are 16-bit, but just the low 8-bit is used by the machine code routines because they are only 8-bit registers. All this math is randomly choosing between character 32, which is a blank, or character 160, that is 32 plus 128, which is a solid square. And so that's just making up when you play the game, and it's filling up with those squares and blanks. That's the code that did that. Okay, so that's lines 100 through 140. 150 is setting a variable for the ship, S, and that's 2003. That's a screen location right down here where the ship starts. Instead of storing its X or Y, I am just directly storing its screen location. And F, I believe, is the fire variable. We'll start that off at 0 because there is no shot being fired. C is for the counter that handles the wall of doom moving down towards you. And E is the number of frames or game ticks, number of updates before the wall descends. It starts at 350. Poke 650, this actually enabled auto repeat. Actually, we could just get rid of line 160. That enables key repeat. One of the iterations of the game, I actually had it using keyboard spacebar to fire and J and L to move left or right, but then I decided to switch to joystick. Jumping ahead to line 200, this is the routine that moves the spaceship at the bottom of the screen. With K, I used K because it was keyboard, but now it's I converted the code to joystick. Again, this is how prototypes go. I'm peeking location 56320, which is joystick port number 2. And then calculating J for the joystick button of K and 16, it's bit 4, that is 2 to the 4, that is the fire button on the joystick. And K equals K and 15, the low 4 bits of the joystick are the directions. So I'm just keeping the 4 directional bits. If K is 15, that means the joystick hasn't been moved, and variable D gets set back to 0. This is like a delay variable that I use to tweak the movement, especially as I was going through all these iterations. Now, if K is not equal to 15, that means that the joystick is being moved in at least one direction, and then the delay counter counts up. And if delay becomes greater than 3 and the J equals 16, that means the fire button is not held down, and we set the delay back to 1. So basically there's a loop here. It counts from 0, 1, 2, 3, 4, and then goes back to 1 if the joystick isn't being held down. I just added this just before I recorded. I was saying if you hold down the fire button, then you have to tap the joystick just to move each character. You can't hold down and it won't continue to move across the screen. So that's how I implemented that, by checking if the joystick button is not pressed and only looping back around to 1 to allow a new movement. So normally this means that you can only move every 4th frame, but if you hold down the fire button, then it won't loop around at all. Well, I suppose it would if you weighed 65,000 plus frames, but that is a compromise I'm willing to take. Okay, now if delay is 1, then it's time for a move on the joystick. We check if K equals 11, that is 15 minus 4, which is the bit for joystick left. On the C64 joystick ports, each bit is set to 1 if the joystick is not being moved in that direction, and 0 if it is moved. So in a sense, when the switch is closed, then it becomes a 0. So this means the joystick is being moved left. If so, then we erase the ship by putting a 32, a blank, in its place. Move the ship left with S minus, just a decrement, to move it 1 character cell to the left, like this. That's -1. And then we check, is S less than 1984? That's a good year. That's screen location 1984. It's kind of cool that the Commodore 64, this bottom row of characters are all the years from 1984. Oh, how about that? To 2023. Last year, we have just lived through the rest of default Commodore 64 screen memory. This is location 2023. Wow. And all the way back here is 1984. And here's 1982. Oh, I missed a really good opportunity to make a video about that. 2023, the end of screen memory. Okay, so, oh yeah, back on topic. Then S equals 1984. So that just limits the spaceship from going all the way to the left. Line 230 is exactly the same, but moving right, because it's bit 3, which is equal to 8. 15 minus 8 is 7. So this means that the joystick is being moved to the right. If so, then increment S and make sure we don't go past 2023. And then, no matter what, we poke the ship onto the screen at its location. So poke S just means poke the ship's screen memory 1, which is that A. And I guess if I ever develop this game more, we would use some custom characters to make a nicer looking spaceship. Okay, from lines 299 on, shot update. Okay, there used to be a whole bunch of logic here where if F equals 0, that's the fire, or firing, I guess. If it's equal to 0, that means there was no shot active on the screen, and I would check the fire button and all this. Well, I got rid of all that because I implemented auto fire. F is 0 when there's no shot active. Then we set F to the ship's location, and that's all there is to make the bullet, the asterisk, the fire, I guess I'm just going to call it a fire. The fire just equals the ship's location. Now we check. If the fire is active, then we're going to, that's why this is kind of like a bug. Oh, I'll fix that later. I want to move the fire up the screen, but first I have to blank the existing fire by poking 32. When the fire spawns or is positioned, it's on top of the sprite, so we're actually blanking the ship. And it's not as easy. Well, first of all, this basic won't actually let me do that kind of math. Plus, I wanted to reposition it. Anyway, I'll figure that out later. So we blank the fire here. We subtract 40 from it to move it up the screen, 40 column screen, and we check. Did it go off the top of the screen? Is it less than 1024? If so, then fire goes back to 0. That means the fire's done because it went off the top of the screen. If fire is still active, then we're going to peek its location and put that in B. And we're going to check, is B equal to 160? If so, it's hit a square in the play field. Then we're going to poke that location with 32 to blank out that square, and we're going to kill the fire, the bullet, set back to 0 again. If after all that, the fire is still active with a greater than 0, then we're going to poke it onto the screen. That's 42 is the asterisk. Okay, so that's all the logic for shooting. Not too much, eh? Okay, and now this next big section here is descending the doom. And this is kind of the last big piece of game logic. C is that counter we have that's counting up the number of game ticks until the doom moves. So we just increment it, we check. Is it equal to the number of steps, which starts off at 350? If so, we reset the counter and we actually move the bullet plus 40. We move it down the screen so that it doesn't miss a collision due to the scroll. And then we decrement E, which is the number of counts. So it starts off at 350. Once it scrolls, then we subtract 4 from it, and it keeps speeding up a little bit. At first, it's not very noticeable, but after many times, it's actually more rapidly advancing. Quite a bit faster, actually. So if C was set to 0, then a bunch of this logic is done. Because Hare Basic and, in fact, Commodore Basic don't allow big if clauses, that's why I'm preceding a bunch of these statements with if C equals 0. They will only get executed when there's a new step. So the first thing we do is set X to 1024 and Y to 1983, which is one line above the bottom of the screen. And we set Z to 2023 and Go 5. And Go 5 copies memory backwards. So the reason we're copying backwards is because we want to shift the screen down, but what we have to do is go backwards through memory. So this line goes down 1, all these characters get bumped down 1, then the next one, and so on. It has to start the bottom, -1 row, and copy it. Because if you started at the top, it would start overwriting itself, and you couldn't actually shift the screen downwards. You have to start near the bottom and work your way up. So that scrolls the screen, and you see how quickly that happens? That would be horribly slow in Commodore Basic. Okay, if C is 0, then we need to do some other things. G is a flag for game over. So we're going to set to 0, and what we do is scan the bottom row after the shift, and we look, are there any blocks that have reached the bottom row? Now, even this would be too slow in Commodore Basic, but in Hare Basic, scanning those 40 characters doesn't take all that long, especially when it's done immediately after the big block copy. That's when the scan needs to be done, and it doesn't really seem to delay the game very noticeably. So we scan, and if we find any 160s, which is the block, then we set the flag G to 1, that we have a game over. Now this is a little bit tricky. This code will end this line. I can't put a next here, even though I would like to, because if this is false, then this doesn't happen. So instead, we again, if C equals 0, then execute the next. And once that whole bottom loop is being scanned, then we check if G equals 1, then we go sub 1200. That's the game over little routine there. And then we go to 100, which starts the game over again, displays the title screen, and so on. Now next, if C equals 1, this is the next iteration of the game. I did this on the next step just so that the game spreads out the computation a little bit. If C is 1, then again we set that flag back to 0 and we scan the top row of the screen and we look for any instance of a block in the top row. And then again we have to do the next on the next line. If G equals 0, that means no blocks are found up in the top row. Then that means we won the game, and we go sub 1100. Okay, then otherwise we go to, just like in that sprite balloon demo, that waits for the vertical blank. Well, sort of. It waits for a raster line near the bottom of the screen, and then it goes back to line 210, back to the ship calculation. So that's the main game loop. Okay, so that's the whole game logic, except here we have the title screen, which is just a bunch of static strings being printed out that you've already seen. I want to add a little delay in case, especially before when the player was having to hold down the fire button. There's nothing worse than a game that ends, you get game over, and then you accidentally start the game again or whatever. Anyway, I always like to put a little delay. This is a 1 second delay for I equals 1 to 60. On NTSC it is. Go to waits for a frame, and it does this 60 times. Okay, and this is just code that's checking the fire button. First, I wait for the fire button to be pressed. So we're just peeking the joystick, checking the fire button bit. If it's not being pressed, then it loops back to 1040. And then line 1050 is identical, except it waits for the fire button to be released. So there's a lot of times in game code where you need to check both for a press and a release. If you only wait for one or the other, then the game will jump ahead when you don't want it to. Okay, and then we just return. Okay, and finally here in 1100, this is the winner routine. Just printing out winner and waiting 1.5 seconds. That is 90/60ths of a second, and returning. Or if you lose, you get game over. That's just the same, except to make the game over message pop a little more, I just printed out a blank square, a blank rectangle above and below and around the game over, just so it stands out a little bit better. Okay, that is a look at Hare Basic. Again, I didn't cover everything, but I think that is a way to start, I really think this is worth checking out. It's just a lot of fun for if you want to prototype a game, or you just like Basic, but you just wish it were faster. This lets you use, most of your basic programming skills. You have to relearn a few things. And if you've been kind of scared of assembly language, this serves two purposes. It will speed up your existing basic programs with only just a little bit of new learning. And the new thing, the way you handle, breaking your program into even smaller steps for the math and so on, and using less variables will get you even closer to thinking in terms of machine code of assembly language. Yeah, I really think it's a win. Some people might think this is dumb. You should use cross assemblers. You should use whatever. You know what? Use whatever you like. I think this is fun, and that's what matters. And if you might think it's fun too, if you don't think it's fun, that's fine. Go do something else. It's kind of wrong to actually just like playing my own game. Okay, anyway. I will surrender to the doom here. Okay, so thanks very much to Alexei Eben for making Hare Basic and all the other things he's contributed to the Commodore scene over the years. Game over. Make sure you check the video description for links to download Hare Basic, the D64, the PDF, which is really well written in my opinion. If you want to play my little Descending Doom game here, make some changes or whatever, there'll be a link for that too. Okay, thanks to my patrons for their support. Thank you for watching, and we'll talk to you next time.
Times 31, answer 930, is the largest product I've ever seen on my little professor. But the most difficult question was 28 times 27, product 756, which was very difficult for me to solve